You've seen how to add, subtract, multiply, and divide rational numbers. You have also seen how to evaluate expressions with rational exponents. In this video, we look at several variable expressions with rational numbers. Let's start with an example. Find the combined areas of these two rectangular shapes, expressed as a variable expression. To find the area of a rectangle, multiply the length and width. To find the combined areas of these two rectangles, simplify this expression. 8.2 times the quantity x plus 5 plus 6 times the quantity 2.5x plus 1. Distribute the 8.2 to this expression and 6 to this expression. We get this expression. Combine like terms. That means combining these two terms and these two terms. The result is 23.2x plus 42 as shown here. Let's look at another example. The vertical height of a ball thrown in the air can be calculated for any time t using this formula. Analyze its height from t equals 0 to t equals 5 in 1 second intervals. We are given the formula for finding the height for any given time t. As t varies, the height changes. Let's look at different values for h for t equals 0 to 5 in increments of t equal 1. We start by setting up a two-column table. In the first column will be the t values from 0 to 5. In the second column will be the values of h for each value of t. Let's fill out the first column of values. As shown here, you can see that there are 6 values of t that we want to evaluate, from t equals 0 to t equals 5. Each t value represents a time value. So at t equals 0 is when the ball is still at ground level. For each t value, we plug in that value in the formula for h in the next column. Here is the first entry. Where there was a t in the original formula, we have substituted a 0 here and here. Here are the rest of the t values with numbers plugged in. In each case, the t is replaced by the corresponding value from column 1. Now use a calculator to evaluate each expression. We show the results here. At t equals 0, the ball is at ground level. After 1 second, the ball is already 59.5 feet up in the air. As you can see, its initial speed of 75.5 feet per second pushes the ball upward quickly. After 2 seconds, the ball is still higher, but not quite as high as the first second launch. In other words, the ball is slowing down. After 3 seconds, the ball is at a lower altitude than it was here. This means that the ball is already falling toward the earth. After 4 seconds, the ball is 46 feet above the ground and continuing to fall. Now look at what happens at the 5-second mark. The formula tells us that the ball is 22.5 feet below the ground. Obviously, the ball would simply land on the ground and would not continue below the surface of the earth. How do we interpret the result at t equals 5? Recall that at t equals 0, the ball was at ground level. When you throw a ball in the air, eventually it will fall to the ground. This ball is no exception. We can see that sometime between the 4 and 5 second marks, the ball hit the ground.